Hi, everyone. I hope you had a great winter break and are ready to get back into the swing of things. This week, we're going to look at lessons 57 through 60. So let's get started. You are going to need your lessons manual, the student's worksheets book, the math card games manual with the game cards, appendix pages 2 through 6, scissors, and either tape or glue. These are not in your Right Start Math supplies. You'll want to have copies of appendix page 6. That would be 3 to 8 different copies. Now, if you have purchased you purchased the book bundle or the appendix pages separate, or we copied them for you, you will not need to make any copies of that appendix page 6. You will also need colored pencils or markers, again, not in your Right Start Math supplies. And finally, you'll need the Casio SL450S calculator or another basic calculator. This week, we are going to do a math project and we're going to learn how to find errors in math. Let's get started by turning to lesson 57. Now, each year in Right Start Math, there is a unique math project that you can elect to work on. For level D, this project is to build and learn about Pascal's triangle. Now, this project is a 2-day project that will cover lessons 57 and 58. Lesson 57 is an enrichment lesson. Actually, both lessons 57 and 58 are both enrichment lessons. That means it is not a required lesson. So if you find that you are behind in Right Start Math, you can opt to skip lessons 57 and 58. You can also choose to skip it for now and then come back to it at the end of the year for a fun project to do at the end of the school year. For lesson 57, you are going to build a 14-row Pascal's triangle. Now, the first page of the lesson will help you figure out how to assemble the appendix pages to make it fit together and build that triangle. It might be easier, and I would recommend, to assemble this triangle prior to the lesson. Let me show you how that will work. So the first thing to note is there are actually several pages for this large Pascal's triangle. You have part 1, which is appendix page 2, part 2, appendix page 3, part 3, appendix page 4, and part 4, appendix page 5. And you are going to want to start by cutting on these dotted lines. Once you get those triangles cut out, you're going to assemble them. So this is appendix page 2 or part 1, and this is going to be the top section of the triangle. Then you're going to line up the other pages. So this is page 3, and that's going to go on the right side, at the very bottom right. I'm going to line that up, this line. And then I'm going to use the other page and line that up here on the left. And then I'm going to take this extra piece and I'm going to line that up as well. And notice your lines are going to overlap. So when you tape it, you may want to tape it on the bottom so as they can still write on the top. So if you tape it to the bottom, that way they're going to be able to write on the numbers over here. On the top of the second page, you are going to explain the project to your child. You're going to explain to them in very general terms who Pascal is. However, you might want to have your child do a little bit more research on Pascal and maybe even write a short paper or essay on Blaise Pascal. Then you're going to give your child worksheet 41. On this worksheet, your child is going to complete the 14 rows of Pascal's triangle that's listed on the worksheet. So, how do you fill in those empty hexagons? Well, you're going to find an empty hexagon and then add the 2 top connecting hexagons together and put the answer in the empty hexagon. Let me show you how that works. So here's the very top portion of worksheet 41. Notice at the very top row we have a 1, and then the next row we have 2 ones next to it. We have this blank row here. What we're going to do is we're going to see this row here, or this hexagon here, and we're going to add the 2 top connecting hexagons. This one has 1, this one has 1, 1 plus 1 is 2. Then we're going to find this next hexagon. We're going to add the two top hexagons. 1 plus 2 is 3. Again, 2 plus 1 is 3. And here we have 1 plus 3 is 4, 3 plus 3 is 6, and then 3 plus 1 is 4. Now take a look at the last paragraph before the section called Filling in the Large Pascal's Triangle. Here, you're going to have your child complete the triangle on the worksheet and then have them check their answers using their check numbers. If you need a quick review of check numbers, look at lesson 54, or you can view our blog online or the video that we have available in the pre-recorded webinars that talk a little bit more about check numbers. The solution for the worksheet is listed on appendix page 6. Now, take a look at the section called Filling in the Large Pascal's Triangle. This is where your child is going to fill in that large triangle that you built from the appendix pages. Because your child already completed the worksheet, they're just going to copy those numbers over onto the large triangle. However, there are additional lines on your pre-created triangle that your child is going to need to fill in. In fact, they'll need to fill in those last 5 rows. They will also need to write very small when those numbers get very large. The suggested math card game for this lesson is the Corners 3 game, which you played prior to the break. All right, let's go ahead and turn to lesson 58. For this lesson, you're going to want to make copies of appendix page 6. I would definitely recommend that you make 6 copies of this page, of the appendix page, so that your child can keep all of those multiplication separate, all of those multiples separately. Now, again, as I mentioned earlier in this video, if you did purchase the appendix pages from Right Start Math or it came in the book bundle, you do not need to make copies of that appendix page. That's in your appendix pages copy. Now on the first page under Pascal's triangle, that example of the Pascal's triangle, you're going to have your child find the multiples of 5 on the triangle from appendix page 6 and color in the numbers with a colored pencil or marker. Now remember, we can find what a multiple of 5 is because they end with 5 or 0. The next section is called Multiples on a Calculator, and this will teach your child a fun way to use the calculator to find multiples. It will give them practice on using the calculator and using it to find multiples. So let me show you how this is going to work on a calculator. So here's how we do the multiples on the calculator. First off, make sure you turn it on by hitting the all clear. When we're working on the multiples of 5, we're going to hit 5 and then divide it by 2 different times. So you'll see this K come up on the calculator. Then you're going to type up any number and see if it's a multiple of 5. So let's see if 10 is a multiple of 5. So we just put 10 and then we'll press equal, and we know that 2 times 5 is 10. Let's try another one. We're not going to clear it, we're just going to put in a number. Let's try 45. Is that one a multiple of 5? Yes. 5 times 9 equals 45. Let's try another number. Let's try 46. Again, do not hit clear or anything, you just type in the next number. 46 equal, notice the decimal place. That means 46 does not go, 5 does not go into 46 evenly. So therefore, 46 is not a multiple. Let's just for fun try a large number, 1, 3, 2, 7, or 6, 8, and just hit equal. We have a decimal place, therefore it is not a multiple of 5. On the top of the second page of the lesson, your child is going to use all of the other copies of Pascal's triangle, appendix page 6, and color in other multiples. So you already colored in one of the multiple of 5. Now you're going to color in the other multiples of 10, 9, 2, 3, 5, 6, and 7. Now what I did with my family is we used one page and we colored each multiple on a different page and in an entirely different color. For example, one triangle, my child colored in all of the 5s in blue. And then in another triangle, my child colored in all the tens, multiples of tens, like in red. And then another triangle, they worked on their nines and so forth. So you kind of get how that worked, at least in my family. That way, your child will color in all of the multiples for 5, 10, 9, 2, 3, 6, 7, and 4. And again, we use different colors for each multiple. There is not a multiplication math card game listed for this lesson. So you're going to want to pick a multiplication math card game to review or continue learning their multiples. Go ahead and turn to lesson 59. We just found a correction for this lesson. So if you have a manual that was printed in 2020 or before, you're going to want to make a notation of this correction. On the bottom of the second page of the lesson, under Building Differences Game, there are the possible problems listed. The problem, that first problem, 89 minus 28 equals 61, is not a possible solution for this game, and I will explain it a little bit later. In the warm-up section, your child is going to work on some problems to solve. If needed, you can remind your child what the order of operations are. The first thing that they do is anything in parentheses, followed by anything in exponents, anything that has exponents, but we don't have exponents yet in their level of learning. The next thing that you do after parentheses is multiplication and division, and then the next element that you do is the adding and subtracting. Take a look at the section called Comparing Subtraction and Addition. Here you're going to work through a word problem using part-whole circles. You're going to want to get your child used to using part-whole circles whenever they see a word problem. It's really going to help them down the road. So you can draw the part-whole circle, but you're going to want to have your child fill in those numbers. Then you're going to discuss the answer. So the problem is 20 minus 7, and they get 13. And then you're going to ask your child, how do you know for sure that 20 minus 7 equals 13? How can you check that? Well, you can know for sure that it is accurate because if you add 7 to 13, you will get 20. And that is the correction strategy that is taught in this lesson. Your child can double check the answer to any subtraction problem by adding the difference, which is the answer to a subtraction problem, to the subtrahend, which is what is being subtracted. And if this answer is correct, when they add these two numbers together, they will get the minuend. Now, take a look at the section called Checking Multi-Digit Subtraction. Read along with me the last paragraph of that page. It says, suppose I think the answer is 3 of this problem. So let me read the problem to you. It says 428 minus 157 equals 331. Suppose I think the answer is 331. Let's see if I'm right. I'll cover up the top number, the 428, and add the other two numbers. If they add 157 to 331, they're actually going to get the number of 488. And if you look on the top of the second page, you're going to ask your child, so is this difference right? And they're going to say, no, it's not right because we got the answer of 488, but that is not the minuend. The minuend is 428. So then you're going to write the problem again, this time using 271 as the answer. And again, you're going to want to have your child add 157 to 271. And here they're going to find that the answer is 428, which is now the correct answer. Take a look at the section called Practice. Here, you're going to write the problem 4,620 minus 3,906. And you are given 3 different possible answers. And your child is going to find the correct answer, not by doing the traditional subtraction, but by doing addition. Adding one of those numbers to the 3,906 and seeing which number will take you to 4,620. Remember, this lesson is working on helping your child learn how to catch errors, not working on their subtraction skills. Now, after they finish that section, go ahead and give them worksheet 42. And they are going to only work on the top part of this worksheet at this point in the lesson. Again, you're going to have them check their answers by adding. The game for this day is called Building Difference building differences game. This is a variation of the game called sum building, and we do have a blog for the game called sum building. It's called Winter's Game Sum Building. Now you're going to play that game, except instead of using addition, you're going to use subtraction. As I mentioned before, there is an error on this particular section of the lesson, and that is the 89 minus 28 equals 61. That is not a possible solution because the student is only going to work with the numbers listed on that second paragraph under the building differences game. They're only allowed to use 1, 2, 5, 5, 6, 6, 7, 8, 9, or 0. So they can use 2 5s or 2 6s in their problem, but they only have 1 8. So therefore that particular solution is not correct. After your child has played the game, your child will complete worksheet 42. Your child will be given a different set of numbers to use to build problems. Instead of the 1, 2, 5, 5, 6, 6, 7, 8, 9, 0, they're going to be giving a different set of numbers. But they're going to do this rest of the worksheet similar to how they played the game. All right, well, let's turn to lesson 60. This lesson has a correction. If you have a lessons manual, or actually if you have the worksheets that were printed before 2018, there is a correction for worksheet 43. If you use the PDF version of our worksheets that you purchased before 2018, you'll want to also double check worksheet 43 for that correction. The warm-up section will again have your child work on some problems. These problems are designed to show the relationship between multiplication and division. The second paragraph of the warm-up will review content from lesson 59. Take a look at the section called Checking Subtraction with Check Numbers. Using check numbers in subtraction is slightly different than when we used it in addition. So take a look at the problem, the two problems that they give you. They give you 62 minus 49 equals 27, and 62 minus 49 equals 13. One of them is correct, one of them is wrong. Your child is going to calculate the check numbers for that equation. So take a look at the numbers, check numbers. Instead of subtracting, we're actually going to add up the check numbers. Difference plus subtrahend should equal the minuend. For example, the first one shows 0 as the difference. So 0 plus 4 does not equal 8. So therefore we know that problem is not correct. Take a look at the second one. The second one says the difference is 4 plus 4 equals 8. So that one is the correct solution. Now, why am I adding and not subtracting? Well, let me use the example at the bottom of the first page to answer that. Take a look at the problem. 3,574 minus 1,958 equals 1,626. Now, we're going to specifically look at the check numbers. The first problem has the solution with a check number of 6 plus 5, which is the subtrahend. So 6 plus 5 equals 11. But when we use the check number, 1 plus 1 equals 2. So we know that is not correct. Take a look at that second problem. 3,574 minus 1958 equals 1,616. Specifically looking at the check numbers. We see the bottom, the solution, the difference is 5 plus 5 equals 10, right? But remember, when we have a double-digit number, 10, we add those numbers up together. So 1 plus 0 equals 1, which is the exact number that's in our minuend check number. Now, if you have an advanced student, you might want to read the section at the explanation section at the very bottom of the first page. This will explain how to subtract check numbers in a subtraction problem. Once you complete those activities, have your child work through worksheet 43. Now, there are a lot of subtraction problems on this page. So if your child is a struggling learner, or if there is just simply too many problems for your particular child to do without getting overwhelmed or frustrated, then there's a few things that you can do to kind of help reduce that amount of work. One suggestion would be to have your child only work through one column. Another idea would be to have your child work through the first 4 or 5 problems in each column to solve. Now remember, have your child use the check numbers when solving these problems to double check their work. In addition to checking the work, making sure that their work is correct, your child is actually going to see a pattern in the check numbers as you work through these problems. So take a look at the explanation section at the top of the second page. It says this: all 3 columns of subtraction end with 0, forming a pattern. The check numbers in the first and third columns also form patterns. In the first column, they decrease by 1, and in the third column, they increase by 1. Those are just kind of fun little patterns that you can see in math, and it's kind of fun to point those out to the kids. The suggested math card game for this lesson is Sum Building Game, which is a variation of what you played for lesson 59. But you're going to be using addition instead of subtraction like you did in lesson 59. That being said, you may want to change that game out for a multiplication math card game if your child still needs practice on multiplication, but especially if they haven't learned all of their multiplication math facts. Well, that's it for the week. If you have any questions or concerns about a lesson, or if your child is struggling with something, give us a call or email us. We are here to help. I look forward to seeing you next week as we cover lessons 61 through 64. Have a great week, everybody.